Okay, so finishing up visibility of lights. We're going to be discussing some factors that can affect the range at which we see a light and even modify the characteristics of said light. Now, we know that the condition of the atmosphere has a large role upon a light's range. Things such as fog, haze, dust, smoke, and even high levels of precipitation can all affect the range we can see a light. Many of us have been out to sea and observed firsthand the impact that low visibility caused by fog can have on the detection of a light. As navigators, we need to be understanding of the fact that meteorological visibility is dynamic and can change for better or worse depending upon where we are in the world. One topic we don't discuss in depth in this lecture is refraction. For this course, when calculating computed visibility, we assume a uniform or homogeneous atmosphere. In reality, the atmosphere is not homogeneous. There are some changes in density and medium. The differences can affect how light moves, thus increasing the range of the light or decreasing the range of the light. For computed visibility, the values will not be severely impacted, which is why we tend to ignore them. But just understand that light waves are definitely impacted by refraction depending upon where you're operating in the world. Now, this one may seem obvious, but low-intensity lights are more easily obscured in poor weather conditions. This is why we like to choose primary lights, high-intensity, high-visibility lights when we were choosing nav aids to confirm positions along our track. Another thing to understand is that the distance from a light cannot be estimated by apparent brightness. Just because a light seems bright or dim does not mean that it is near or far. There are way too many factors that go into play with this. If you want a good example, on days where the moon has a high illumination and rises in darkness, observe it as it comes up. It is apparently bright, but definitely not close. No risk of collision. Or pay attention to the side lights on ships in the early morning hours. There were many times as we were making our way inbound to Norfolk where we would have to get relatively close to ships. I would walk out on the bridge wing, and I was astonished at how many times I observed the dim sidelights of cargo ships in relation to their distance to us. Do not make the mistake of believing that apparent brightness is a good tool to gauge range, because it is not. And now, because of these factors, every light should be carefully evaluated to confirm that it is expected where it is at. Remember, sometimes a light may be extinguished. This can be due to a number of factors such as weather, battery failure, or even vandalism. Be proactive in searching for lights that should be along your track. If they are not where they are charted, report it in accordance with Appendix Echo of the NavDorm. Understand that if a light is not sighted within a reasonable time after prediction, in accordance through CO's night orders, of course, a dangerous condition may exist. Because of this, we want to fix our ship's position immediately using an alternate fixed source to determine if we are steering into danger. Landfall navigation is an extremely important evolution. Confirming that GPS position by alternate means is imperative to safe navigation. Furthermore, it will enhance your watchstander's situational awareness and make them better. We do not want to be the next case study. Well, that does it for Visibility of Lights lecture. In summary, we talked about horizon distances of both the light and the observer. Taking the sum of both yields us the geographic range. We discussed where and how to find nominal range and meteorological visibility. Using these two values along with the luminous range diagram, we determined how to find luminous range. We determined, based off of the lesser of the two values of geographic range and luminous range, what computed visibility of a light was. We also discussed light characteristics and factors that can affect their ranges. We hit all of our enabling objectives and were ultimately able to calculate the computed visibility of a light and plot it on our chart. If there are any questions on this lecture, please get with a SurfNav instructor to clarify. That concludes the Visibility of Lights lecture. Have a great day.